the square. We do need to get it equal to 0 before we start. Well, now, for the most part with completing the square, as long as the x squared term and the x term are on the same side, we don't have x's on both sides, we don't have x squareds on both sides, we can start. But if you're not sure if it's set up correctly or not, just get it equal to 0. If you get it equal to 0, it's a good place to start. After that, we can move on to step number 1. Is a equal to 1? If not, make it so. So we just need to make sure that the number in front of x squared is 1. If it is, we just move on to step 2. If it's not, we divide everything by that amount. Now, if the starting problem, if it started out as just x squared minus 6x minus 12, the number in front of x squared is already 1. I don't have to do anything, because if a is equal to 1 is the main question. Is a equal to 1? If it's not, make it be 1. We need it to be 1. Step 2, get the variables on one side and constant terms on the other. And leave 2 spaces. So what we have to do here is we have to add 12 to both sides. Bless you. Notice that we have x squared minus 6x plus blank equals 12 plus blank. We have our x squared and x term on one side. We have our number without x on the other. We have our 2 spaces. Now that brings us to the third step, to find c, which is equal to b over 2 squared, and plug in. Now at this point here, you're going to have a lot of space, because especially on the test just like this here, there's only 2 of the completing the square problems that you have to do, and they're both on the same page next to each other. So I'd probably drop down to the bottom of the page to find the value of c that we're going to have to plug in. I wouldn't put it right under our problem, because again, we're not done yet. We still have to solve. So move it or put it in some place where it's not going to get in the way. Now our value of b in this case is -6. So we're going to divide it, if it is possible, divide it. -6 divided by 2 is -3. -3 squared is 9. So it tells us our value of c is 9. And we can plug it back in. We can put it in its 2 spots. Questions on this here? Last step is to factor and solve. So we are going to factor the left-hand side, our x squared minus 6x plus 9. It'll be a set of parentheses squared. And the number and sign that goes inside the parentheses with x is our number and sign inside the parentheses before we squared it to find c. Since it was -3, we get x minus 3 squared. Now we do have to combine the like terms on the other side. 12 plus 9 is 21. And last but not least, we need to solve. We're going to take the square root of both sides. Here, the square root and square would cancel. Minus x minus 3 is equal to plus or minus. Now we do need to see if the square root of 21 will simplify. Second square root of 21 is lastly, we do need to get x by itself, so we're going to add 3 to both sides. Whenever we add or subtract a number and we have that plus or minus, the number that we add or subtract has to go in front of it. So since we added 3, we get 3 plus or minus the square root of 21. Now we can say we are finished as long as 3 and the square root of 21 are not like terms. If 3 and the square root of 21 are like terms, then we need to add and subtract. But 3 and the square root of 21 are not like terms, because if, when we take that square root of both sides, if that radical does not reduce completely, we're not going to be able to add or subtract. So if we got either I, a term with I, or we still have a radical, or both, we have I and a radical left over, they're not going to combine. If it just reduced to, say, 21, we can do 3 plus 21. We can do 3 minus 21. We can get 2 answers. Questions on this here? Questions on anything we've done so far? Questions on how we completed the square? Quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. We'll look at 27. Now the first part of the quadratic formula is that we need to get the equation equal to 0. We need to get the equation equal to 0 before we can start solving. So here we're going to, since we have negative 4x squared on the right-hand side, we're going to add 4x squared to both sides, because negative 4x squared plus 4x squared is 0. Tell me I have 4x squared minus 7x plus 6 is equal to 0. We do need to find a, b, and c. A is the number in front of x squared. B is the number in front of x, and c is our number without a variable. So a is 4, b is negative 7, and c is 6. So we do have to take the sign in front of them. For a and c are going to be positive. C is our negative value. So we have negative b, so negative 7, plus or minus the square root of, so b squared would be negative 7 squared, minus 4 times a, so 4 times c, which is 6, all over 2 times a, so 2 times 4. So the two places b shows up, we're replacing those b's with its value, which is negative 7. The two places a shows up, we're replacing it with 4. And the one place c shows up, we're going to replace it with 6. Questions on this here? Now our negative 7. Negative and negative make a positive, so just 7. On bottom, 2 times 4 is 8. Now I wouldn't put the radical, but I would put everything inside the radical into the calculator. Telling us that we have negative 7 squared minus 4 times 4 times 6, which is negative 47. Now, if we had typed the square root with it, well, the calculator will tell us the 30xs, I can't take the square root of negative 47. But it does reduce, at least a little bit, because we know that the negative is going to come out as I. I will count off if you do not take that negative out as I. Because we've got to take that negative out as I, leaving us with the square root of 47. And the square root of 47 is square root of 47. Now we can see if it reduces any further from here if we look at the top two terms and our bottom term. So the 7, the term outside the radical I and 8, there is no like term between all three. So what that tells us is this is as simplified as it gets. With a lot of these simplifying steps, I would write them out step by step as we have them. If there is a common term in all three, we will simplify it out. We'll divide it out of all three spots. But here there is not, so it just tells us x is equal to 7 plus or minus I square roots of 47 all over 8. Questions on this here? Are you ready for the next one? If the discriminant b squared minus 4ac is greater than 0, we have two real solutions. If b squared minus 4ac is equal to 0, we have one real solution. And if b squared minus 4ac is less than 0, we have two complex solutions. Greater than 0 is two real, equal to 0 is one real, less than 0 is two complex. So for these here, we need to find the value of the discriminant, our b squared minus 4ac, and then determine the number of solutions, either two real, one real, or two complex. Now, before we can start finding any of this out, we do need to make sure the equation is equal to 0. So our 4x squared is equal to 5x minus 10. I'm going to subtract 4x squared from both sides. Those are going to cancel, telling us 0 is equal to negative 4x squared plus 5x minus 10. Now, the other thing we could have done is we could have moved the 5x over to the other side and the 10. So we could have subtracted 5x from both sides, added 10 to both sides, and also got it equal to 0. But personally, I would rather move the one term, the x squared term only, instead of moving 2. And the reason we're doing this is we need to find the values of a, b, and c. Now for us here, the value of a is negative 4, value of b is positive 5, and c is negative 10. Now we want to find b squared minus 4ac. So we're going to plug 5 in for b, negative 4 in for a, and negative 10 in for c, giving us 5 squared minus 4 times negative 4 times negative 10. At this point here, I would just grab a calculator. 5 squared minus 4 times negative 4 times negative 10, which is negative 135. And that's the first part of our answer. Now, if b squared minus 4ac is greater than 0, we have two real solutions. If it's equal to 0, we have one real solution. And if it's less than 0, we have two complex. Well, negative 135 is less than 0. So we have two complex solutions. That's it. That's all I'm going to be looking for on the test. It's not going to ask you to solve it. It just needs you to find the value of the discriminant, our b squared minus 4ac, and then determine if we have two real solutions, one real solution, or two complex solutions. That's it. Questions on this here? Questions on anything so far? We good with 28. Let's look at 30 before we move on. Need to subtract 24x from both sides. Now this tells us that 0 is equal to negative 3x squared minus 24x minus 48. So again, the first thing we need to do is get the equation equal to 0. It helps us find the values of a, b, and c. A is the number in front of x squared. B is the number in front of x, and c is our number without a variable. So a is negative 3, b is negative 24, and c is negative 48. Now to simplify from here, we just have to plug those values into b squared minus 4ac. And once we plug it into the calculator, hit enter, it tells us it is 0. So the value of our discriminant is 0, which means we have what? One real solution. Yep. If that value is bigger than 0, we have 2 real solutions. Bigger than 0, we have 2 real solutions. Equal to 0, we have 1 real solution. And less than 0, negative number, we have 2 complex. That's it. Questions on this here? Questions, anything so far? We ready for the hardest part of the test? Oh, no, sorry. We have one more thing before that. Perfect square trinomial. We want to find the value of c that will make it a perfect square trinomial so that we can rewrite it as a single set of parentheses being squared. So here, c is equal to b over 2 squared. So looking at 31, x squared minus 24x plus c, what's the value of b? Negative 24. Now, as we're finding this first value, the value of c, the first thing we need to do is c is 24. Negative 24 divisible by 2. Can we reduce that? Yes. Negative 24 over 2 will reduce to negative 12. Now, at this point here, we can square it. Negative 12 times negative 12 is going to be 144. Now, if you want to rewrite it as x squared minus 24x plus 144, by all means you can. I'm just looking for that value of c. Because it just needs us to find the value of c that will make it a perfect square trinomial. And then we need to factor it to a single set of parentheses being squared. Now inside that parentheses being squared, we will have x. And the number that goes inside that parentheses with x is the number in sign inside the parentheses before we squared it to find c, which is negative 12. Telling us that it will factor to x minus 12 squared. And that's it. So yes, we can do it that way, but the number and sign is kind of matches it up. So it makes it a little bit easier, a little bit quicker than having to actually factor it out with 2 sets of parentheses and then rewrite it. And it's kind of especially true with like 32. Because for 32, x squared plus 29x plus c, what's the value b? 29. Does 29 divide by 2 nicely? Nope. And we can double check and make sure, because we can grab the calculator, say 29 over 2 is, well, 29 over 2, which means we're just going to go on and square the whole thing, telling us it's 841 over. Now this here, 841 over 4 is half our answer, but we still have to factor it. So we will have a single set of parentheses being squared. Inside that parentheses, we will have x. But the number and sign that goes inside that parentheses is our number and sign inside the parentheses before we squared it to find c, which is 29 halves, telling us that the x squared plus 29x plus 841 over 4 is going to factor to x plus 29 halves squared. Questions on this here? Questions on anything we've done so far? We good with this here? Yes? We good with finding our value of c that makes it a perfect square trinomial? Yes? All right, here comes the hard stuff. Powers of I. Simplify powers of I. We take whatever that exponent is and divide it by 4. If the decimal we get is 0.25, we know that reduces to I. If it's 0.5 or 0.50, it's going to be -1. 0.75 is negative I, and 0.00 is just 1. And for the most part, if we get 0.00, unless we specifically set the calculator up to give us 2 decimal places regardless of what the decimal is, it's not going to give us a decimal if it divides evenly. It's just going to give us the number. So if we get 0.00 or no decimal, we know it has to be 1. So the first one we had is I to the 27th power. So we can take 27 and divide it by 4, which is 6.75. 0.75 corresponds to negative I, so it's going to reduce to negative I. 287 divided by 4 is also 0.75, so that gives us negative I. We can move on to 41 divided by 4 is 0.25, so I. 2,874. 2,874 divided by 4 is 0.5, so that would be -1, and 6,971. I think that's also negative I. 0.75, so negative I. Now we could plug it into the graphing calculator, but once we get to a certain power, it starts giving us this pixel error, because the way the graphing calculator calculates it is not, it actually has a setup. It's actually trying to graph it. It's graphing it. And once we get to such a high power, we do have a pixel error, and that's what that first part is. So for these here, especially once we get to these higher powers of I, we might as well just divide it by 4 and look at the decimal. Questions on simplifying powers of I? Questions on this so far? We ready for the next set? A, B, C, D. Which one of these do we want to look at first? A? So when we first went over these here, we would look at the parentheses, see we need to drop, if we can just drop them, or if we need to distribute a negative through. We did that and then combine like terms, yes? We did that for a few of the problems, then we realized what? We can take the graphing calculator and go what? 6 minus 7 second decimal for I, plus 4 minus 3I. So 6 minus 7I plus 4 minus 3I is 2 minus 10I. Yep. And that's it. Questions on this one here? We feel good about this one here. How about B through D? Is there one of those that y'all want to look at? Yes, no? Because B through D, we can just say what? We can take it and plug it straight into the calculator. How about E? (189) I minus 361 I squared plus 71 I squared minus 38 I to the 4th. Even though we have I squared and I to the 4th, even if we had I cubed, even if they squared one of the parentheses, We can type it into the graphing calculator exactly as we see it. It's going to do all the work for us. Questions on this here? F through K, multiplication, which one do you want to look at with F through K? H. So we have 2 plus 3i times 7 minus 4i times 6 minus 2i. Multiplication, we can type it in exactly as it is, and it'll tell us the answer, 182 plus 26i. Graphing calculator, we don't have to do a thing with it. We type it all in exactly as it is, and we get our answer. You might want to put a note on your sheet to get the decimal, or get I on the graphing calculator. It's second decimal. Even though I does show up as a green letter, that is not our imaginary number I. Second decimal gets us I. So do we feel good about multiplication? Division. We cannot type it in as a fraction. We cannot go alpha y equals enter for the 84 plus. Now the 84 plus CE, the color edition, will let us do it. But for us to do these here in the calculator, we have to rewrite it as the numerator divided by the denominator. We need to put them in parentheses, even if it is just a single term, like 6i, put it in parentheses still. Put the top in parentheses divided by the bottom in parentheses. So for this here, we would get 8 minus 4i divided by 3 minus I. And once we get our answer, we're going to go math. Enter. Enter. So we can grab the calculator and go 8 minus 4i divided by 3 minus I. And when we hit enter to find it originally, it gives us this here. But again, as I said, we're going to go math, enter, enter. We want to turn it into a fraction. So we get 14 fifths minus 2 fifths I. And that's the answer. Now the review sheet has 14 minus 2i over 5. Those are the same answers. The only difference is that the second answer broke it up into two fractions instead of leaving it as a single fraction. They are the exact same answer. Questions on this here? Questions on how we got this answer? We feel good about these here. All right. We ready for the next one? Next type. Complex conjugates. If we're given a plus bi, the complex conjugate is a minus bi. If we're given a minus bi, its complex conjugate is a plus bi. So if we're looking for the complex conjugate of 4 minus 3i, it's going to be what? 4 plus 3i. We're changing the sign in front of I to get the complex conjugate. So half the answer for this is 4 plus 3i. Questions on this so far? Now the other half is to find the product. So to find the product, we're going to take 4 minus 3i and multiply it by 4 plus 3i. We're just going to multiply them together. Now we can do it by hand, or we can say 4 minus 3i times 4 plus 3i. We will need to use parentheses in the graphing calculator because otherwise it would just multiply whatever the middle terms are only. And when we multiply these two together, we get 25. When we multiply complex conjugates together, we should just get a number. The I term should cancel out completely. Questions on this here? Questions on anything so far? So what would 18 plus 14i's complex conjugate be? 18 minus 14i. And that'd be half the answer. The other half would be multiplying these together. Now we should expect to get a decently big number. $520. And that's it. Questions on this here? Let's look at S. 8i's complex conjugate would be negative 8i, because again, we're changing the sign in front of the term with I. So if we have positive 8i, its complex conjugate would be negative 8i. So finding the complex conjugate negative 8i would be part of it. The other part would be multiplying the two together. And it would actually give us positive 64. Because our 8 times 8 would be 64, negative 64. 8 times negative 8 would be negative 64. Our I times I is I squared. Well, I squared is negative 1, so negative 1 times negative 64 would indeed make it positive. Questions on this here? Let's do one more. I'm going to add this to it. Let's look at U. Let's say U is 8. What is 8's complex conjugate? It is not negative 8. It is, because what are we changing? We're changing the sign in front of the term with I, yes? So really we can consider the first one 8 plus 0i, yes? Which means its complex conjugate is 8 minus 0i. But 0i and negative 0i really isn't adding anything, so it's just telling us that the complex conjugate of 8 is, well, 8. And if we multiplied it together, 8 times 8 is 64. I don't think I put one of those on the test, but if I did, it's not too bad. It just really gives us the number back. And then we just multiply it by itself. Questions on this here? That is the entire review sheet.